Well, let's see. You got your pliers, got your hammer, got the screwdriver. Have you ever been working on a home project and get so frustrated, get so stuck, and finally you call a professional and they come in and they're like, oh, you just need one of these, and they pull a Dumaflac out of their bag and you're like, I didn't even know that existed. If I would have known that, it could, right? You see where I'm at, right? And it's the same thing in the world of technology. The first step in learning network address translation is to figure out what tools you have at your disposal. And so in this nugget, we're going to focus in on the forms of NAT, essentially the tools of NAT that we have, and determine when each type of tool is useful. And the first thing that we're going to do is shift our perspective a little bit, because we've been focused so far on the inside of the network. We've been looking at, setting up our IP addresses, subnetting, VLANs, getting our routing going from one site to another so that we can have full internal communication, because that's important. It's fundamental to everything. But we live in the world of a cloud, in the internet, and where most of the resources that we access are out there somewhere. But we also live in a world of IPv4 right now, where we're out of public IP addresses, and there's far more devices in the networks of today than we have IP addresses to do. So what's a network engineer to do? Well, what we're to do is to start using things like NAT, network address translation, so that we can set up our private internal addresses, these VLAN subnets that we've defined for Arizona and all of the other sites that we would have connected to our Metro E, Nevada, Florida, et cetera, and all the devices that would come across that private internal network using private addressing and be able to reach the outside world by using a public address, perhaps 203.0.113 dot something, right? Now, the way that we can do that, and I'll define let's say there's probably, I would say, three primary ways that we can do. And there you'll see others out there, but I would say they're all kind of derivatives of these three methods. The first method that we have, and the most popular method in the world, is known as Nat Overload. What Nat Overload is, and by the way, some people call this PAT. You'll hear it in a lot of documentation listed as PAT, which stands for Port Address Translation instead of Network Address Translation. I'll totally explain why in just a second. Nat Overload should be called, in my opinion, NAT sharing or something like that, right? Because it allows you to share public IP addresses for hundreds, if not thousands, of internal devices that are all trying to use that address. Now, the name PAT is there for a really good reason, is the way it accomplishes that. The brilliance behind NAT, if you will, is by using all of the individual port numbers on an address as kind of like separate addresses. Here's what I mean. Let's say we've got a device inside, right? Let me just kind of back up for a second and say, what if we lived in a world where, we lived in the world of IPv6, right? Where everybody had their own public IP address, but we're talking IPv4 right now. So let's just imagine that our organization purchased like for our site, let's just say we needed like hundreds of addresses. So we got, let's just say we got this whole block, right? 203, well, I can't even write it. I'm flustered. .0.113.0/24, right? We got 254 public IP addresses. And we said, okay, you, computer, actually get a full-on public IP. You would get 203.0.113. Let's just say 100 is your IP address, right? If we did that, we would have no need for NAT. This guy would go out to the internet and he would say, hey, I'm coming from a source of 203.0.113.100 with a port number. By the way, this is where the source port number comes in of, let's just say 11,100, right? Now that you remember that source port is generated by Windows. When that computer opens a web browser, it's like, boom, there's Chrome. I'm going to go to cbtnuggets.com, right? It will actually generate a source port number for that application to go out. So when the website, cbtnuggets.com, communicates back to me, my computer knows exactly what application to give that data to, right? So It's going to play an important role in just a second. And it's going to send it to a destination. Let's just say this guy is 1.1.1.1, just so I don't have to write as much. 1.1.1.1, colon, and let's just say we're using HTTPS, which is the most popular in the world right now. 443 is what port number that goes to. That's your destination port. And by the way, not dist, this combination of IP address and port number, you guys know what that creates? It's called a socket, right? So we're communicating from this source, from that source point. That's your source socket, if you will, going to this destination socket. It's the combination of both those things, right? Okay, so that would be how we would work if everybody had public IP addresses, but they don't, right? Poof, they're all gone, just like that. We have private IP addresses. So what Nat Overload does is actually use those port numbers. That's, again, why it's called port address translation to its advantage, right? So let's, instead of having a public IP, let's just say we've got 10.16.4.100 is our computer's IP address right there. So it's going out. It's like, hey, I need to access the internet. So it's going to its private gateway right here. Now, what this guy can do, and this headquarters routers will just say, is he can say, okay, I see that you're trying to access the internet. I recognize your private IP address because the administrator has configured me to recognize that, is not going to be allowed to access the internet. So I'm going to do Nat Overload. It's a configuration type where I'm going to allow you to transfer through and use, let's just go simple. Use the public IP address that's assigned to my interface. I'm going to make sure you know. Doesn't have to do that. Could be a different public IP address. But what most people do, at least in small environments, is they use the public IP address assigned to the router's interface and they share it. Now, the way that they share it is by using those ports. So this guy, is going to cbtnuggets.com. His computer said, I'm coming from a source port of 11,100, right? And I'm going to CBT Nuggets, which is 1.1.1.1 on port 443. So in its memory, the router creates a table. It says, okay, I see the source of 10.16.4.100 on port number 11100, right? So I'm going to send that out. My public IP address, 203.0.113.2. That's our IP right there. And I'm gonna borrow that same source port number, 11100, right? And so I'm gonna tack that on there, and so that will be a nice unique address. So then multiply that. Hang on, I want that to soak in for a second. Got it? Okay. So multiply that among all the clients. You've got a smartphone attached to the Wi-Fi, right? It has a private IP address, 10.16.4.101, right? Another computer right here. And they're all coming from their different source port. Now, hang on. Whoa. How many port numbers are there, Jeremy? 65,536. That's a lot of port numbers. So that means our router could so I'm just going to say, in theory, here's theory land, our router could actually take that one public IP address, 203.0.113.2, and share it amongst 65,536 internal devices because it could actually use unique port. No, okay, whoa. Whoa. Hey, whoa. Questions that come up when I throw this kind of thing out there. What if somebody just happened to generate the same source port? Now, what if there's another computer that's like, I want to use 11,100? What then? Well, that's okay. That's why we call it PAT. It'll come in, so this guy got there first, so he gets 1100, right? But routers are smart because somebody programmed them to be so. So when 10.16.4.101, let's just say that smartphone just happened to generate the same source port number, 11,100, and so it's going to come in as, I think it just stole his IP address, as 11,100 as well. But the computer, the router, I should say, will realize, oh, I'm already using that. So let's just use the next one in order. 202.0.113.2:11101. It's cool doing that. It's a table, right? It comes back. So when the return traffic comes, it's like, oh, it came in on 101. Oh, I'm looking at my table. Let me translate that port. PAT, port address translation. That's what it does. And so again, theoretically speaking, 65,536 devices could share one public IP. That's why Nat was such a lifesaver when it comes to the internet. Now, okay, that's the theory. Give me real. Well, first off, no, you would never have 65,000 some hosts use that because that'd be too big of a network going through one router sharing one IP. Second thing is computers eat up sockets like cereal for breakfast. I mean, you're gonna open an application, it's gonna use 5 sockets just out of the bat, and then you access a couple websites, you're using 100 sockets per computer because it's going to all these different redirected sites and image hosting sites. So it's not going to be that much, but still, I mean, it's fair to say you could use one public IP for 1,000 internal devices. That's safe, right? 2,000 devices, but you could max out. Let me make sure I mention that. You could max out that one public IP address and say I'm out of ports. And at that point, it starts deleting Nat mappings, which causes all kinds of, I lost my connection, all that kind of stuff, right? So that's why a lot of times you'll create a pool of addresses. Let's just say .3, .4. That's why I showed a /29 here, and we'll get more into that. For now, I love Nat. I do. It's one of my favorite topics to talk about. So forgive me, but at least I just wanted you to get right now what it is. We'll talk more about how it works in just a moment. So that's Nat Overload, the most popular form of Nat. The second form of Nat is known as static Nat. And static Nat does a one-to-one mapping usually for traffic instead of going from the inside out, although that is valid. It will usually be for traffic coming outside in. So let's just say we have a server right here. Maybe it's an email server, right? That we want to send and receive email from the outside. Well, what we would set up on this router is a static Nat mapping because an email server probably has a private IP address. Let's throw it in that server VLAN 10.16.0.50. Let's just give it that address. And what we can do is we can say, but I want to actually map that to 203.0.113. And let me just throw this out there, .3, right? And I could say, so when this email server goes out to the outside world, I want it to assume the identity of that IP address. And if the outside world comes back in and accesses that, I want it to assume the identity of, or I should say translate that back in to 10.16.0.50 so that server actually receives that. Now, you can do that with the full IP address to where you say that's the, and I would actually, Jeremy Char would personally suggest if you're running an email server, probably want to do that. And the reason why is because a lot of times your email reputation is tied to that public IP address. I don't know if you ever go to what website? I think it's mxtoolbox.com. If you go there and do an IP lookup, they will show you the reputation tied to each one of the public IP addresses. And that's because there's so much spam going around the world that if there's a spammer, they want to find them out quick and then lower that reputation so it goes into the proper junk email and all that kind of stuff. So usually the public IP of an email server you want to protect really well, right? But you don't have to dedicate that full public IP to the email server. Like for instance, email. Let's just talk. Email. And by the way, when you get into NAT, you're going to want to know some port numbers. A lot. Actually, not a lot. Maybe like 8 of them. Let me give you some key ones. They're all, well, almost all TCP based. You'll want to know 21, that's FTP, TCP port 21. 22 is SSH. 23 is Telnet. You'll want to know, that's because that's a common port number that you'll see. You'll want to know 80, HTTP. You'll want to, that's what I was forgetting. Port, we're talking about email too. Port 25, SMTP. That is your email server protocol. So as emails come in from the outside world, it's flying in, right? It's going to come in on SMTP. And as your email is relayed from your organization out, it's going to go out on SMTP. Whereas port 110 and 143 is actually POP3 and IMAP. Those are your email client protocols. So somebody opens, Outlook, for example, and goes to check their inbox from their computer. It'll go to the server and it'll use, so if they're in the outside world, let's just say somebody is, trying to access email from home. Most of the time, it'll use IMAP or POP3, right, as one of the protocols that'll go there. And I would just take a big jump, 443 HTTP S, or a lot of people will just say that's SSL, secure socket layer, that is used. So you'll want to make a quick note of those. On the UDP side, really only one that I would say you should absolutely know, and that's port 53, which is DNS lookups. You could throw down port 69, which is TFTP, but not as important at all. I would say DNS is the one that you want to know there. So what got me on that today? Oh, email. We're talking about email. So what I could do is I could say, okay, well, that email server right there only really needs port 25, maybe IMAP or POP3 IMAP, and maybe HTTPS. Maybe it's hosting webmail, or you're using a feature called Outlook Anywhere, which allows Outlook to connect to email servers all through HTTPS, through SSL. As a network administrator, I can go in and I can say, I want to do static. I guess you could. I've never used this phrase before, but I'll do it now. I want to do static PAT. Right? To where I actually just say, if somebody comes in and accesses this IP address on port 25, I want it to go to that email server, or port 110, or 443 for SSL, or 143 for IMAP. Right? So just those 4 port numbers I want to come in. But I've got another server up here. Let's just say it's just a web server, right? An unsecure HTTP web server. So I could set it up to where I kind of stretch this IP address, right? To where I could say, okay, if somebody tries to access my router on 203.0.113.3 on port 80, right? Then that I will forward into that web server. That'll work just fine too, right? So we can actually stretch one IP address using static NAT, kind of static PAT, to where we take individual ports and send them to specific destinations. That's cool because it allows us to stretch the public IP addresses that were assigned beyond what they were used. Sensing, little question rolling around some people's mind. Let's see if I can get you here. You guys said now this screen's becoming a mess. I want you to just look at this for a second. I'm going to screen it, clear it off. I drew up 203.0.113.3, right? And I said, okay, static. Now, I know some of you were looking and you're like, whoa, wait a sec. I thought 2 was assigned to the router. How did you set up 3? Well, know that first off, this is a /29. So we do a little reverse subnetting and we would find out 203.0.113. What would that be? It'd be 0 through 7 would actually be assigned to us. 8 would be the next subnet, right? So 1 through 6 is quote unquote usable IP addresses in that range, right? This is what I really want to convey to you, and this throws a lot of people at first. That subnet, so if you were to go to the ISP's router right here, because they have a router, right? They actually have either via BGP or more likely static. They've got a static route set up that says, okay, to reach this subnet, go right here to that router, right? That's how they know how to reach you, and then they send that in their whole system so they know how that works, and that propagates out using BGP to the rest of the internet. So that whole subnet comes to you. So you'll have stuff coming to you that's going to IP addresses that may not be assigned to that interface of your router, and that's okay. We set up NAT on the router that when it sees those, it's like, oh, .3, okay, I got that. That's to me, and I can translate that in. It could even be things outside of this subnet. I mean, I've seen where you've got a subnet assigned between you and the ISP, and actually, I've seen this happens all the time. And the ISP will say, well, I'm also going to route this subnet and this subnet, and however much money you want to pay for all your subnets. We'll route all these subnets straight to you, so you might not have anything to do with these subnets and create NAT translations on them. And as they hit the router's like, oh, I recognize that because somebody configured me with NAT translation to forward those in, right? So much stuff going on right now in this NAT concept. So let me throw you the third type of NAT, and then we'll jump into the address types in the next video. So third type of NAT, clear this off for a second, is dynamic NAT. This is probably my least used version of NAT. What this is it can be used two ways. I would say one that I use a lot more often, and one that I hardly ever use. It is where you can translate a pool of addresses to and from another pool. It can be used in a network mess for example, to hide, let's just say like duplicate addresses. So let's just say, we've got our company right here. And let's just say we acquire another company. So here's another company. And when we acquire them, we find out that they were using the same addresses that we were using. And we're like, address overlap. Well, we can't just merge those two networks together. Now, obviously, this is very small, but it might be much, much larger. We can't just merge those two networks together because we'll have duplicate addresses all over the place. So what you can do is you can set up dynamic NAT in a way that says, okay, when I access these guys up here, let's just say this is AC. This is the acquired company, right? When I access these addresses through the HQ router, I'm going to translate my addresses to something that they don't have. So even though I'm duplicate addressing, these guys never see that. They're like, oh, you came from 172.16. something, right? Because I went from a pool, let's just say 10.16.00 over to 172. So we can do it on a one-to-one basis. So as a computer that's .50 on 10.16.0 accesses acquired company, passes through the router, and as it comes out, it's 172.16.0.50, right? So the acquired company is like, oh, well, that's totally unique. I'm good with that, and transmits back. And as they come back, they translate to a different pool where your guys recognize them as totally, 192.168. So that's the flavor of dynamic NAT that I never use because it's a mess. And it's like, I'd rather readdress the network than live in that world if at all possible. And I'll just say that's one bucket. The other bucket I do use. And that's where I was saying that you've got one public IP address here, but maybe you've got an organization big enough that 65,536 ports is not enough for you to use. So in that case, you can configure a pool of addresses that you're overloading. So what you can do is say, I want to overload all of these addresses out to a pool, which is technically Nat Overload, but a little bit of dynamacy, my made-up word, to it, to where maybe you use .2 as the first IP address, but once that's maxed out, I use .3 and .4 because they've been assigned to me by the ISP, and start maxing out all of those, to use port numbers from there. That would be doing Nat Overload to a pool of addresses, and that's a form of dynamic NAT. Cool? Got your hammer, right? Those are the types of NAT that we can use, and I will be expanding on those more and more as we dive deeper into the NAT configuration and look at the different types and the terms that we can encounter. So for now, we have looked at the forms of NAT, 3 of them: Nat Overload, static NAT, and dynamic NAT, and determined when each type is useful. I hope this has been informative for you, and I'd like to thank you for viewing.